Okay, so this is a quick video on Newton's law of cooling. Okay, so Newton's law of cooling is about a temperature difference between an object and its surroundings, how the temperature of the object changes over time. The given formula is T of T equals T sub S plus D naught times e to the negative KT. Okay, so T of T is the temperature after time T has passed. T sub S is the temperature of the surroundings, the room, the environment, whatever the object is placed in. D sub naught is the initial temperature difference between the object and the surroundings. K is the constant for the object, and you usually have to find this first in a problem. Usually you're given enough information that you can fill everything else in and solve for K. And then lowercase t is time. Okay, so let's use this to solve the following problem. Okay, we have a cup of coffee that has a temperature of 200 degrees Fahrenheit, and it's placed in a room that has a temperature of 70 degrees. After 10 minutes, the temperature of the coffee is 150 degrees Fahrenheit. So we're going to use this information to find a function that models the temperature of the coffee at time t. Basically, we need to find K first, and we know the initial temperature difference. So let's start there. So D naught is the initial temperature difference. So the room is 70, the coffee is 200 degrees at the beginning, so 130 is our temperature difference. The temperature of the surroundings is 70 degrees. Okay, and let's see, our formula is T of T equals T sub S plus D naught e to the negative KT. All right, so we're going to fill in everything that we know here. Okay, so it says after 10 minutes, the coffee is 150 degrees. So 10 minutes has passed, and we're at 150 degrees. The surroundings are 70. D naught is 130 times e to the negative k, 10 minutes. Okay, so we filled everything in except for k, so we're going to solve for that. So I'm going to subtract 70 from both sides. 150 minus 70 is 80. Okay, and now this is an exponential equation, so I want to isolate the exponent. So divide both sides by 130. I'm going to leave this as a fraction because dividing by 13 is a mess. Okay, because it's base e, I'm going to take the natural log of both sides. So now I have the natural log of 8 over 13 equals, ln cancels out the e, and we're left with negative 10k to solve for k, divide by negative 10. So I'm just going to be very careful putting this in my calculator. I'm going to do the natural log, parenthesis, 8 divided by 13, and then divide by negative 10. And when I do that, let's see, 8 over 13. All right, I get a k value of 0.045. Okay, so there's my k value. So then for part A, I have everything I need to write the function. Okay, so my function is T of T equals 70 plus 130 e to the negative 0.04855t. Okay. All right, part B. Find the temperature of the coffee after 15 minutes. So we can use our formula. Our formula is in terms of minutes. So I just put 15 in for T. All right, so type this whole thing on your calculator. It makes sense that the temperature should be a little lower than 150 because that's where we are after 10 minutes. It should continue cooling. Okay, and I have the temperature is 132.8 degrees Fahrenheit. Okay, now it says for part C, when will the coffee have cooled to 100 degrees? So whenever you're looking for when, that's going to be an exponential equation. So it's just going to be a little more work to solve for T. So I put 100 in for my temperature, and I keep everything else the same. Okay, so to solve for T, move the 70. Okay, and then divide by 130. Okay, and I'll just leave this as a fraction. I'll just leave it as 3 over 13 equals e to the negative 0.04855 t, natural log of both sides. Okay, and so I'll have the natural log of 3 over 13, and then this will cancel out. I'll be left with this exponent on the right side, so then we'll need to divide by 0.04855 to get t. And let me just put that in my calculator. So all right, and I come up with 30.24 t. So 30.2 minutes. Okay, and then we're not going to worry about graphing this right now. Okay, and that's it. That is Newton's law of cooling. Okay.